Have you ever needed to take the derivative of a function but did not know or remember how to do it? Chances are you can use the chain rule to find that derivative.
We can start explaining the chain rule by relating it to something simpler that more people might remember, the composition of functions. If f of x equals toast and g of x equals an avocado, then f of g of x is avocado toast, and g of f of x is toast on an avocado.
So, the composition of functions occurs when one function becomes the input of another function, just as g of x replaces x in the f of x function. Mathematically, this can be written as this or this, which is said as f of g of x. For example, if f of x equals 2x plus 12 and g of x equals x minus 9, then f of g of 4 equals 2 times 4 minus 9 plus 12, which equals 2.
If you work backwards, you can also identify composite functions, or identify f of x and g of x in one function of f of g of x. For example, in the function y equals 3 times 3x plus 4 plus 1, if it is f of g of x, then the f of x could be 3x plus 1, and the g of x could be 3x plus 4.
Now you may be wondering, how does this relate to the chain rule?
If you have a function that can be viewed as the composition of other functions, you can use the chain rule.
This is the formula for the chain rule. It's defined as the derivative of the outside function with the inside function plugged in for x times the derivative of the inside function. Do the words plugged in ring a bell? They should.
Let's put the definition to action in an example. Say we have the function f of x equals 3 sine of 5x plus 2. First, separate the outer function f of x and the inner function g of x. The outer function would be 3 sine of x, and the inner function would be 5x plus 2. Now, we can find the derivative by taking the derivative of the outer function and plugging it in the inner function for x, which is 3 cosine of 5x plus 2.
Now the crucial part. Do not forget to multiply by the derivative of the inner function.
Done! Now you have found the derivative of f of x equals 3 sine of 5x plus 2 through using the chain rule. We can also use a table to find the derivative of functions at a certain x value. For example, when c of x equals f of g of x, then to find the derivative at a certain x value, which in this case is the derivative of the x value 3, all we have to do is apply the chain rule.
We can plug given values into our equation that we found using the chain rule. First, we can find the value of g of 3 and plug it into our equation. Then we can find the first part of our equation, f of 5. Then, finally, we can find the last part of our equation, g of 3. Multiply together, and bam, c prime to 3 is 60.
You can also apply the chain rule in other ways, like implicit differentiation.
Don't let the long name intimidate you. It's just differentiating each side of an equation by treating one side, the y side, as a function of x using the chain rule. To help you remember, think of implicit differentiation as a function being implied in the middle of an equation. With implicit differentiation, we can find the derivative of y with respect to x without having to solve for y or the given equation, which means that x is just a variable and other letters are actually functions of x.
To find the derivative of a function using implicit differentiation, there are a few steps that make it super simple.
Another way to apply the chain rule is through related rates, which are like derivative word problems. and they usually involve some geometric shape that is changing over time. Like implicit differentiation, related rate problems can be solved with certain steps that make it clear and easy. In related rates problems, derivatives are taken with respect to time, which means that the variable time, which is t, is like the x variable. Every other variable is treated like y was in implicit differentiation. Also, in related rate problems, rate means derivative.
Another tip, if a related rate problem says the height is increasing at a rate of 5 meters per second, that means that the derivative is 5 meters per second. We can solve a related rates problem using 4 steps. We can use an example problem to go through these steps in action.
The chain rule is one of the core principles of calculus that helps us find derivatives. And finally, to help you remember it, here's a short jingle.
If you want to find a derivative, the chain rule is imperative. To start, you find the outside prime, then stick the g of x inside. But most important part is multiplying g prime with the heart.